So we'll start with electric charges and fields. Have you attended demo class?
Yes, sir. I
Or
attended
when?
maths
Okay.
and chemistry.
All right. So for physics, this is your first class with me, right?
Yes, sir.
So we will start with electric charge and fields. So the very first concept is that is property of charge, basically properties of charge. We are mostly familiar with, like, we know the quantization of charge, conservation of charge, additive properties of charge. So that we all know, and mostly the questions are asked. Generally, questions are asked from quantization of charge, right?
Yes, sir.
Quantization of charge. So in JE, most of the time, generally questions are not are generally in Neet. Sometime they may ask question from quantization, but for the sake of concept, we will do one question based on quantization of charge. Then we will move to distribution of charge. So
Yes, sir.
quantization of charge, we already know that is charge on any object is integral multiple of
In E.
plus minus elementary charge, where E is the elementary charge, and we know that it says that, like, we can have charge like minus E plus 2E plus 3, but we cannot have charge like half E, right? 1 by 3. We cannot have these charges, right?
Yes, sir.
So now, based on that, suppose I am giving you an example, like, suppose charge on any body is like this. Charge of an object is, like, it is given that charge on the object is 8 into 10 to the power minus, like, 15 Coulomb. So whether is this charge possible or not? So we have to identify whether this charge is possible or not. We have to identify. So how will you identify whether this charge on an object is possible or not?
Sir, we find if it's an integral number. If
So
it's
how?
put Q is equals to any,
All right, then.
it is an integer.
Okay, so when n is an integer, so what we will do is we will equate it with the ne, right? So we will equate it with the n into e. What is the value of e?
Sir, I don't remember.
It is 1.6 into 10 to the power minus 19,
Yes, sir.
right? And we will put that equal to 8 into 10 to the power minus 50. So you calculate n. What is the value of n you are getting? Tell me.
Sir, 5 into 10 power 4.
All right. So that is an integer. You are getting n value of n as
5
5
into
into 10 to the power
4.
4. Maybe are you sure you are getting 4 or 5? Oh, okay, we are getting 4, correct. So that is integer. So yes, you can say that yes, this charge is possible, right? So this
Yes,
is
sir.
the basic property of quantization of charge. Moving ahead, now we have like some distribution of charge. This is generally moving ahead, distribution of charge. This concept is distribution of charge. So in the distribution part, we will see how the charge can be distributed. Charge can be on any object like on point object, or it can be on, uh, rigid object also. So in
Yes.
this, we will see different charge distribution, surface charge distribution, volume charge distribution, as well as uh, linear charge distribution. So mainly we have three type of distribution of charge. One is known as linear charge distribution, linear charge distribution, linear charge distribution. So this is basically denoted by, generally we denote it by lambda, and which is equal to charge per unit length. Its unit is Coulomb per meter. And like we will have examples like, suppose I have a rod having, it is an infinite, long rod. So in such cases, we cannot calculate total charge, or we can calculate, but generally these kind of charges are, mentioned by, or these charges are represented by their linear charge distribution or linear charge density. So this is basically called linear charge density, right? LCD, linear charge density. So we say that this object is having 4 Coulomb per meter, 5 Coulomb per meter charge is distributed. So we mention in that way for long charge distribution.
Yes, sir.
Similarly, we have like surface charge distribution. Surface charge distribution. This is basically denoted by, generally we denote it by sigma, and it is given like charge per unit area. So obviously its unit will be Coulomb per meter square. And example of such distributions are like, we may have charge sheet. So long charge sheet. So in such cases, we will mention that its surface charge density is sigma. Sigma can have any value like 5 Coulomb per meter, 10 Coulomb, 5 micro Coulomb per meter square, like that. And apart from that, we have another is volume charge distribution. Volume charge distribution. These all are scalar quantities. We know the charge is also an scalar quantity. So volume charge distribution, as the name, it is clear that it will be, according to the name itself, it is clear that it is the charge distribution on a volume. It could be on any shape, like it could be a spherical kind of thing. So this is generally we denote it by rho, and its unit is Coulomb per meter cube. Sorry, we may have like a cube, and so these all objects will be three-dimensional object, and they will have charge distribution. So in such cases, we will denote their charge distribution by rho, charge per unit volume. It may be like cylindrical, it may be spherical, it may be shell, could be anything, right? So, and one thing we must know that there is a difference. Suppose we have a conductor. So in case of conductor, mostly all charges will be on the surface, right? We will see it later on also. So in case of conductor, most of the charges we cannot give charge within a conductor. If you are distributing a charge, you cannot give the whole charge within the volume of a conductor. So this is the difference. Sometime you will get conducting a sphere. You will have term like conducting a sphere, conducting a sphere. So conducting means all the charges on the surface. We cannot have volume distribution of charge on a conducting material. But if someone is saying the charge is fully distributed within the volume, so it must be non-conducting. It must be non-conducting. So on a non-conductor, we can give charge within the volume, right? But in case of conductor, all these charges appears on the surface. Getting my point? So
Yes.
like you have like you have a cricket ball, so kind of that is a non-conductor, so you can distribute whole charge within the volume. Every point of the volume can have charge, but in case of conductor, within the volume charging is not possible. All the charges you will give within the conductor, that will come out to be at the surface. All right, so this is the basic difference. Hello Afia, Afifa Mannan. So this is also your first class, right?
Yes.
So just we have started electric charges and field chapter, and we are discussing the very basic concept, that is distribution of charge and what are the properties of charge, like quantization of charge. So I think most of you are familiar with these terms. So we will jump to the question after these discussions, and we will have we will get better idea by solving question. So that is the main concept of these classes. We are getting concept by solving questions. Whenever theory is required, I am going to dictate. All right. So volume charge distribution. In volume charge distribution, we are distributing charge within a volume. So Afifa, you are preparing for NEET or JEE?
Sir.
You are preparing for NEET. All right. So in this class, we are doing both the question. We are doing basically first we are doing NEET questions, and then we are doing JEE questions. So that NEET is also useful for JEE students also, because such questions are asked in JEE main also, and to getting the basic concept also. And then we are doing some JEE main level and some advanced level question. So that is the basic layout of our classes. So till now we have discussed, you can see the slides. First we have discussed like uh, property of charge, that is basically quantization of charge. We have discussed all other properties. We already know additive properties, conservative properties. That is most of the time we are familiar with that, but most typical property is quantization of charge. So I have dictated some idea about that. Then we have done one example based on that, whether this is charge is possible or not. So if we get value of n as integer, then it means this charge is possible. After that, we have done distribution of charge. What kind of distribution of charges are possible? So mainly we have studied three type of charge distribution: linear charge distribution, that is lambda. We all are familiar with that. Then surface charge density, charge per unit area. Then we have discussed volume charge distribution. So first, moving to a question based on these discussions. So let us do a question, so that this is basically so this is basically JEE main 2019 question. Very good question. A Neet student may face some issue in this typical question, because this may require little bit of idea of integration. So Neet student, just get the idea. You may skip this question, but and from chart distribution mostly no questions generally asked, but this question I found has been asked in JEE Main 2019. So both of you try this question. Uh, After that, if you are able to solve, that will be better. Then I will solve it. So both of you try this question. This is based on chart distribution. Can both of you see the question?
Yes, sir.
Okay. This is JEE Main 2019 question, phase 2. Any idea how to solve this question? Are you trying, both of you?
Yes, sir. Sir,
Okay.
since rho is equals to delta Q by delta V,
Yes,
um,
yes.
but, we equate both the equations, and then
Okay.
delta Q is equals to A by R square E power minus 2 R by A into delta V, and then we integrate it.
So the main thing is how we will find delta V.
Yes, sir.
How to find delta V? Delta V is unknown quantity, right?
Yes, sir.
So how to find delta V? You are going in the good direction. So that is good. But after that, the main question is how to solve, how to find delta V. What will be
Sir, so the volume of a sphere,
the
4 pi
volume
R,
of a sphere?
4 pi R cube.
But that is volume of sphere. But you have to find differential volume,
Yes.
right? So good. What we are doing is basically this is a volume charge distribution. So suppose like we have a sphere like this. So first what we will do, we will consider a kind of shell, right? Suppose I have taken a shell of, a sphere can be assumed to be made of number of shells, right? So suppose I am taking a shell of radius r having thickness dr, right? So what, and we wanted to find volume of this part, right? We will find volume of this part. So what is the volume of this part? Suppose it is dv. What will be its? We know the surface area of a shell is 4 pi r square, and its thickness is dr. So volume of this shaded portion will be 4 pi r square dr. Now I think you understand how to proceed now. Got my point? We got dv. So we know that charge distribution is It is given in the question, which is a by r square e to the power minus 2r by a, and that is equal to charge per unit volume, right? dq upon dv. So from here we can calculate dq, which will be equal to a by r square e to the power minus 2r by a dv. Getting my point?
Yes, sir.
So from here we can calculate the total charge q. So q will be equal to total charge q, that will be equal to integration dq, and it will be equal to e to the power minus 2r by a 4 pi r square dr, and it was I think a, right? So
A by R square.
a by r square, a by r square. So a by r square, right? A by, so here we will get a by r. So now we can see that r square and r square will be cancelled out. So we will get it as 4 pi a e to the power minus 2r by a dr. And in the question, value of total charge is given as capital Q, right? So, and it is integration of that 0 to r will vary from 0 to r. So do you have any idea of integration? Obviously I know Afifa may not have done such kind of basically we are teaching it in the basic mathematics class. I don't know in your basic mathematics class this have been taught or not. So if it has been taught, it's okay. Otherwise, whenever such kind of basic integrations or differentiations are used, I will tell you the basic concept so that you can understand the things. So you know, when you have some idea of integration, right? Little bit, both of
Yes,
you.
sir.
You know,
Yes,
if
sir.
you have an integration of exponential thing, right? And integration of ex to the power x
EX.
dx is also remains same.
Yes,
But
sir.
if you have some kind of like e to the power ax dx, so you
Then A into
yeah,
E.
so always remember, in the coefficient, the constant which is multiplied to the variable term gets divided. So we will get e to the power ax upon a. In differentiation it got multiplied, but in integration the constant term is over here is a, right? This one, this always gets divided. So this is how integration is done. So here we will apply the same concept, nothing complicated, the thing will remain same. We will take constant outside and its integration will be same, e to the power minus 2r by a, and we will divide by constant. What is constant here? 2 by a. Understood?
Yes,
And
sir.
we will take the limit. So this is how we can proceed. So now it's very easy. We have to put upper limit and lower limit value. So 4 pi a, we will get it as like q is here, 4 pi capital A small a. So this we will get minus 2, right? So this we will get minus 2, 2 pi a divided by a, and then e to the power minus. In place of r, we will put capital R. So you get like 2r by a, and then e to the power minus 0, right? In place of r, you will put 0. Understood it?
Yes, sir.
We have to put upper limit and subtract, and then we have to put lower limit. This is how we put the limits in integration. So we will get it as like e to the power q, we will get minus 2 pi, what What was the value? Minus 2 pi a capital A by small a, and in the bracket we got e to the power minus 2r by a, e to the power minus 2r by a, right, and e to the power minus 0. What is the value of e to the power minus 0?
1.
1. Are you sure, Afia, Manan? Is it 1?
Yeah.
Why it is 1? Can anyone say why it is 1? We always remember e to the power anything power 0 is 1. Why it is 1? Have you ever thought that? Sorry, 1. Why it is 1?
Since there is nothing to multiply it with, like,
Nothing to multiply.
for example, if you have 2 power 0, then it basically means that the 2 is not being multiplied with anything, neither by itself. So it will end as 1 as the result.
If it have not been applied by anything, then why not it is 0?
So like it's a formula that x bar 0 is equals to 1. So here x is e. So
Okay, why x power 0 is 1? Again, the question remains same. Two pi a upon a e to the power minus 2 r by a minus. Now what we have to do here is, so after this question I will say why it is 1. So let us see. This is q is minus 2 pi a divided by a. Then we got this. And what was the question? What we have to find? We had to find. Let us check. What was that? We have to find if charge q is equal to, then we have to find the capital R, right? We have to find capital R. So from here we can find it out. How to find it? Your all mathematic concept will be revised here. So it is 2 pi a like this, so we got it minus 2r by a minus 1, right?
yes, sir.
So from here you will get e to the power minus 2r by a minus 1 is equal to again same thing. So this can be equal to 1 minus qa upon 2 pi a, right? So from here what we can get is,
So do we take log on both sides?
okay, we got e to the power minus 2r by a equal to 1 minus qa by 2, 1 minus qa by 2 pi a, right? This we got. So from here what we can do is, we can take like cross things. So e to the power 2r by a, right? E to the power 2r by a will be, that will be reverse, that will come in denominator. So it will be 1 minus qa by 2 pi a, right? So
Yes,
from
sir.
here you can write it like this: 2r by a will be equal to log of e 1 by 1 minus qa by 2 pi a. So from here you can get r. The value of r will be equal to a by 2, right? Log e 1 by 1 minus qa by 2 pi a. This is our final answer. So r is equal to a by 2 log of e 1 by 1 minus qa by 2 pi a. So see which option matches with this. I think this one is option B is correct, right? A by 2 log 1 by 1 minus q by 2 pi a. Got it?
Yes, sir.
So this is how we should. So the concept was only to here. You know, physics is not much involved there. Here, basic is the mathematics involved. You have to apply the concept. Physics only is that rho is equal to dq by dv, right? And then after that we have mathematics. You have to put the value of rho, then integrate it, and you will get q. Then from that you can find r. So this was the basic concept behind that. Generally, question has not, your question is not asked in the JEE main based on charge distribution, but this question I found, so I thought to share with both of you. So both of you understood this? Any doubt till now? You can ask.
No, sir.
All right. So this is how we should proceed for charge distribution. Now coming back to the, I was asking the question, why that is 1? Like why x to the power 0 is 1, right? So actually uh, we don't think generally in that direction. We generally what we do, we by heart the concepts. And if you think little bit, like suppose like x to the power 0, you can write it like p minus p, right? P is any number, so you can write x to the power 0 as x to the power p minus, right? Can we write it or not? If p is any number, like I can write 0 is x to the power 2 minus 2. Can I write it?
Yes, sir.
So it will be x square by x square. Wow. Will it be 1 or not?
Yes, sir.
So this is how it comes 1. Got it? So this kind of tricks in between I will give you some time if I found something. Okay. So now moving to next concept. So this is how we have discussed about charge distribution. Then moving to the next concept, that is very first concept is Coulomb's law, right? So
Yes, sir.
that is very important part of this chapter. So now coming to the next part, Coulomb's law. Any doubt till now, both of you?
No, sir.
Afifa, Manan, are you getting the things? If you have any doubt, please ask. So moving to the next question, next concept, Coulomb's law, which we already know that if there are two charges Q1 and Q2 and separated by some distance r, so we know that force acting between the charges is k q1 q2 by r square, and we know that if charges are positive, then force is repulsive. If charges are positive and negative, force is attractive. If both the charges are negative, force is repulsive. So, and if the charges are negative positive, then again force will be attractive. And we know that the force acts along the line joining the charges, right? So force on one will be like, if it is attraction, it will be along the line joining two charges. It is always along the line joining the two charges, and it is basically valid for 2-point charges, right? It is valid for 2-point charges, 2-point charges at rest. We apply this formula, and we know that what is k here?
1 by 4 pi epsilon.
Yes, k is 1 by 4 pi epsilon naught. This we already know that concept, and its value is generally we take 9 into 10 to the power 9, and we know that epsilon naught is 8.85 into 10 to the power minus, what is the value of epsilon naught is 8.85 into 10 to the power minus 12, I think. Please check. 11 or 12?
12.
It's 12. 8.85 into 10 to the power minus 12, and it is so it is 1 by 4 pi epsilon naught, right? So it will be, its unit will be Coulomb square per Newton meter square, right?
Yes, sir.
So generally we will use 1 by 4 pi epsilon naught, that is 9 into 10 to the power 9, and this is the basic concept, and more concept we will get by solving the questions. And
Sir,
sometimes yes,
can you re-explain the plus plus 2r plus minus 2a?
you
That
know,
one.
if the charges are positive, both charges are positive, R for repulsive.
Yes. Okay,
If
sir.
both
I got it.
charges are positive, we got repulsive. If plus minus attractive force, minus minus repulsive. It means same kind of charges repel. Very basic idea you all have,
Yes, sir. Got it.
and similar kind of charges repel, and opposite kind of charges attract. Okay, and we have vector form of also we have vector form of Coulomb's law. Vector form is like, suppose the charge q1 is having position vector r1 and charge q2 is having position vector r2, then generally vector form is not used in the solving questions. Generally in board exams, you may have sometimes they may ask like to write vector form of Coulomb's law, but we will use basic formula 1 by 4 pi epsilon naught q1 q2 by r square. So it is written like force on uh, this is F1 means force on q1, force on q1 due to q2, force on q1 due to q2. So we will write it as 1 by 4 pi epsilon naught or k q1 q2 and r1 minus r2 divided by mod of r1 minus r2 cube. So this is the basic idea of, you know, we write in vector form. So if we are taking with respect to anyone, here taking we are force due to q2, so subtract r2. This is the basic idea which we should have. The term or the charge with respect to which you are finding the force, if you're finding force with respect due to q2, then subtract q2, right? Similarly, if you have like f12 force on 2 due to 1, so it will be reverse. If you have f21, then what will be the formula? K q1 q2,
Q1, Q2,
yeah,
R2,
r1, sorry, r2
R2 bar
minus
minus.
r1. The formula will be reverse, and this can be r2 minus r1 or r2 minus r1. It will not make any difference since it is a modulus of that. So mod of a minus b or b minus a are same. So, so the magnitude part, the denominator part is not going to make any difference whether you're taking r2 minus r1 or r1 minus r2. Numerator is b. So with respect to, so the basic thing is you have to see with respect to which one you are going to find the force. If you're finding the force due to q2, then subtract r2. If you're finding the force due to r1, then subtract r1. Understood?
Yes, sir.
Both of you got it, Afifa?
Yes, sir. Yes.
All right. So moving to the question part, I will start with first very basic question. and not so easy question. Sometimes a student makes mistake in that. So suppose we will see example first. Suppose you have two charges like Q1 and Q2, and the separation between the charges is like D. So the question is find minimum force, find minimum force between Q1 and Q2. This question seems to be pretty easy, but it is not so easy. You have to think a little bit here. So both of you try this question. You have two charges Q1 and Q2 separated by a distance D, and you have to find minimum force between Q1 and Q2.
So
Right?
do we find the minimum?
Yeah, you have to find the minimum force. Minimum possible force, I can say. That will be the better language or better sentence to say. Minimum possible force. You may have to differentiate, you may have to see how it could be minimum. Getting my question?
Yes, sir.
Two charges are given. Separations could be anything, like suppose 2 meter, 3 meter, 4 meter. I assume it as D. So charges are variable. Q1, Q2 could be anything. So right,
Sir, is it 1 by 4 pi epsilon?
all right. So Karthik got 1 by 4 pi epsilon naught. He got 1 by 4 pi epsilon. Okay. So let us see. Here the charges are Q1 and Q2 and the separation is D. So how we can find it? We know that force between the charges is F is equal to 1 by 4 pi epsilon naught Q1 Q2 upon D square, right?
Yes, sir.
So now we have to find F minimum, right? So to find F minimum, 1 by 4 pi epsilon naught, we know that D square is fixed, right? So
Yes, sir.
Q1, Q2 should be minimum,
Yes, sir.
right? Now, what is the Q1, Q2 minimum value? Generally, a students will say that it is Q1 should be 1 coulomb, Q2 should be 1 coulomb. So it should be equal to 1, right?
Yes, sir.
But actually, this is not correct. 1 coulomb charge is a very big charge. We have just studied in the property of quantization of charge is that the minimum charge possible is E. Got my point? The
Yes, sir.
minimum, what is the minimum possible charge? Electronic charge E. It is
Yes, sir.
not 1 coulomb. 1 coulomb is very big charge. So it should be E into E, right? So it should be equal to E. The main concept is here. Other thing is we also, it should be F minimum should be equal to 1 by 4 pi epsilon naught E square by D. 70% students are making mistake in this, and they generally give, someone will say 0, someone will say 1 by 4 pi epsilon naught 1 by D square, but basically it is that. Got it?
Yes, sir. Yes, sir.
This is the very basic questions based on Coulomb's law, which we avoid it, and teachers also generally don't explain these. I think this should be taught after Coulomb's law in every class, so that a student can have some kind of idea how to use that quantization of charge in the formula of Coulomb's law. All right, so this is the answer: 1 by 4 pi epsilon naught T square by D. Moving to the next basic question based on Coulomb's law. Let us do one more question. Do this question. This has been asked in Neet 2019. So do this question. I think Afifa dot disconnected. To solve this question,
Sir, I got the answer.
how much you got?
Sir, I got B. 9f by 16.
You got 9f by 16. I think your answer is correct. Let us check. So it says that that 2-point charges A and B having charges plus Q and minus Q respectively are placed at a certain distance. This is Neet 2019 question. So like we have charge plus Q and minus Q, and suppose distance is D, and the force acting on them is F is equal to K Q square by D square, right? And it is given as F. All right. If 25% of A is transferred to B, so what will we charge here? It will remain 3Q by 4, right?
Yes, sir.
And what will be here?
Minus 3q by 4.
If 25% charge is transferred, so minus Q plus Q by 4. So it will be minus
3q by
3Q
4.
by 4. Now we will again find the force Q1, Q2, and so the extra term is 9 by 60,
Yes, sir.
right? So the correct answer is B. Understood it? Very basic question. It has been asked in NEET 2009.
Yes, sir.
Okay. Moving to 1J questions. And so the second thing is that suppose in such cases, if we have more than you may have idea, like if we have number of charges present anywhere, and if you have to find the force on a given charge, so what we will do, we will take the vector sum, right? If we have like two charges over there, like charges q1 q2 is there, and we have to find force on the third charge q. So this is the very basic concept that we have to take vector sum, right? So that idea I think you have. If suppose two forces are, that is called principle of superposition. So if number of charges are present, we will take vector sum of all the forces, right?
Yes, sir.
So based on that, this question is based on that. So try this question. This is NEET 2019 question. To solve it,
Sir, is it minus q by 4?
Yes, I think your answer is correct. I don't remember the answer, so let us check it.
Yes.
So, uh, let us see. So, according to the question, we have three charges plus q, q, and plus q are respectively at the distance d. So, suppose we take origin like this. So according to the question, like so
Sir, 1 plus q charges placed at origin. Uh, Small q is placed d by 2 and plus q is placed at d distance, right?
yes, yes. Three charges are placed respectively at the distance d by 2 and d from the origin on the x-axis.
Yes.
Three charges are placed respectively at distance
I think
plus q
like
is at the origin. Yes, plus q is
yes,
at the origin.
yes,
Yes, plus q is at the origin. Then one charge is d by 2. Suppose this charge is q and one charge is at d. So so according to the question, the net force experienced by the charge placed at the origin is 0.
so
So
f1 plus f2 is equals to 0 and f1
yes,
will be equals to minus f2. So that
yes,
way,
yes. I think you did the right thing. So force acting on this is 0. So suppose what we can take is we will take the individual forces, and if the force, if force on this is 0, it means uh, obviously, suppose this is a plus charge, right? So it will also repel it, and this will also repel it. So net force cannot be 0. So plus values are ruled out, right?
yes, sir.
It cannot be plus, it should be negative. Now the fight is between this and this option. So I'm trying, to solve it. I will give you meanwhile or time to time, I will give you some, basic tricks how to eliminate options also. Every time we don't need to solve the question because we have limited time. So sometimes, in every paper, there are some two or three questions which can be also solved by option elimination method easily, right? Now the
Yes, sir.
fight is between this and this, whether it will be minus q by 2 or minus q by 4. So if you see here, the q is in middle. So if it is q by 2, suppose this charge is q by 2 and this charge is q, right?
Yes, sir.
And you know the force is not linear. Force is inversely proportional to square of distance, right? So if it could have been linear, then for q by 2 distance should be q by 2. Getting my point? For d by 2 distance should be d by 2, but here the force varies with square of distance.
Yes,
Understood what I'm trying to say?
yes,
So
yes,
it
sir.
cannot be q by 2.
Yes,
Getting
sir.
my point? So it should be minus q by 2. So in a
Okay.
just in a fraction of seconds also you can solve this question without solving the in detail. Especially Neet, this is very important. Optional elimination method is very important. Sometimes two option is we can easily eliminate, and generally there is fight between two option. But if you try little concept, you can also eliminate the third one. And the regular method is that obviously what you were saying, total force we will equate to 0, and we will equate F1 F2 equal to 0, and then we will get the value of charge. Got my point?
Yes, sir.
So this is how we should proceed for by applying Coulomb's law. All right, moving to next question. Let us solve one more JE question. So this, let us try this question number 3rd of
Yes, sir.
value. We'll crop it. Try this question number 3rd. This is JE Main 2019-18 question.
Yes, sir. Sir, is it never mind.
How much you got?
Sir, I'm doing.
Okay.
Sir, can I tell the concept?
Yeah, sure.
Sir, so if C is uncharged and it starts with A, if charge in A is Q, then A will be Q by 2 and C will be Q by 2.
Yes.
And if C is touched with B, then C will be Q by 4 and B will be Q by 4.
Yes.
So, and then we find the force between A and C. I mean A and B. Q by 2 and Q by 4.
Yes, I think you're right. The same concept will be applied. So here see, it says two identical conducting spheres A and B carry equal charges. So like we have two spheres A and B carry equal charges. Suppose charges are Q and they are separated by distance much larger than their diameter, and the force between them is F. So suppose initial separation is D. According to the question, F is equal to K Q square by D square, right? A third identical charge is uncharged Sphere C is first touched to A. So now what will happen if it is in contact with A, right? So equal charge will be distributed. So here it will be q by 2 and here it will be q by 2. Getting my point? Then to B. So a third identical sphere C is first touched to A, then to B. Now when it is touched to B, what will happen? The charge will be like this, q2 plus q by 2. Getting my point? Half of total charge. So it will be also not q by 2, sorry, q by 2 plus q by 2, q by 2 plus q by 2. So it will be equal to 3q by 4, not q by 4. Getting my point? It will
Yes, sir.
be 3q by 4. So now we have to find the new force. That will be F dash. That will be K. The charge on. So we have to find the force between A and B, right? So charge on A is now q by 2 and charge on B is now 3q by 4 by d square. So we will get it as 3 by 8 q square by d square, and k is also there. So it will be 3 by 8 f. Understood?
Yes, sir.
So D is the correct answer.
Yes, sir.
Generally what we do, generally we take q by 4, but we don't have to take half of that. We have to take q2 plus q by 2. Getting my point?
Yes, sir.
So this is the thing how we should proceed. Let us do one more question based on that. Solve this question number 6.
Yes, sir.
This is JMIN 2013 question.
Sir, electrostatic equilibrium means F net is zero, right?
Yes, yes. Equilibrium means anytime if there is equilibrium, total force must be 0.
Sir, is this question related with Newton laws of motion also?
Both concepts are there. You have to apply the concept of mechanics also. So let us see what it says.
Yes.
It says that two balls of same mass and carrying equal charge are hung from a fixed support of length L. At electrostatic equilibrium, assume that the angles made by each thread is small. Okay. The separation x between the balls is proportional to. So what will happen is that suppose we have a fixed support and when two charges are suspended, so and they have equal charge, obviously because of repulsion they will get apart, right? Two balls of same mass and having equal charge. Suppose charge on each ball is q and mass of each ball is m. When they will first, what will happen, they will place like this, but due to repulsion, since they have equal charges, they will repel each other and they will get apart like this. Getting my point?
Yes, sir.
This is the fixed support. Now string length is L at electrostatic equilibrium. So what will happen is when they will move apart, there is tension developed in the string which will also start to act. Because of that, at some point of time they will become stationary or equilibrium. So we have to find the relation between, suppose when they get equilibrium, the separation between the charges is x. So we have to find a relation between x and L. We have to find relation between x and L. So suppose when they get separated and stays like this, suppose angle between vertical and thread is angle theta, right? We will assume that. Now what will happen? There is a tension acting in the string. Suppose that tension is T, and due to both the positive charges, suppose this charge is having plus Q, this charge is plus Q, there will be a repulsive force acting on each of the charge. We are only concentrating on one charge. So suppose a Coulombic force F will also act on this, right? Along this line. Suppose this force is actually, that force will act on both the charges, electrostatic force. I am concentrating on ball A. So suppose force is F is along left direction. Obviously that is repulsive. Now what will happen? It is in equilibrium. So we will break the forces, component of forces. Like tension will have a horizontal component and vertical component. If this angle is theta, this angle is also theta. And in this string the tension is T. So the component along vertical direction, what will be component along this direction? Can you say? What
Sir,
will be component along this direction and this direction?
sir, vertical component will be t cos theta,
Correct.
and down and the lower one will be t sin theta.
Correct. Low horizontal component will be T sin theta and vertical component will be T cos theta. And there is also weight of the wall. Suppose mass is M, then its weight will
G.
be mg. But
Yes.
since it is in equilibrium, it
And
means
equals to t cos theta.
yes, T cos theta will be equal to mg, we can
Yes.
say, and T sin theta will be equal to F. Getting my point?
Yes, sir.
So we will divide both. So we can say that tan t sin theta upon t cos theta will be equal to f upon mg. So from here, what we can write, tt will be cancel out tan theta. Tan theta will be equal to f upon mg. Understood?
Yes, sir.
Now, there is one thing given in the question. What is that? It says that assuming that the angle made by thread is small. It means theta is small basically. Theta is small. It means
Yes,
when angle is small, we know that tan theta is approximately equal to theta. Getting my point? When angle is small, tan theta is approximately equal to theta and approximately also equal to sin theta. So
yes,
when
sir.
theta is small, you can write it as theta or tan theta or sin theta, all will have same value. And what is will be the value of sin theta here? You can say that x by 2 from the triangle, if this angle is theta and this is x by 2, right? So that is perpendicular upon hypotenuse. So it will be x by 2l. So what will be that? X upon 2l. Getting my point?
Yes, sir.
So from here now, from the above equation, you can say that value of tan theta is x upon 2l and which is equal to f upon mg. And we also know that the force F is constant if when the and also what will be the value of x, you can write there. What is the value of Coulombic force? That will be equal to k. Suppose charges are q, so k q square by x square. Getting my point or not?
Yes, sir. So,
So F
so
will
the
be k q square by x square. So
answer
writing
is
in, yeah, so it will be like this: x upon 2l will be k q square by x square into 1 by mg, right? It was f by mg, so it will be like this. So from here you can write like x cube will be equal to k q square by mg into l. Getting my point?
yes, sir.
And this the term in the bracket is constant. So from here you can say that xq is proportional to l. So from here you can say that x proportional to l to the power 1 by 3.
3.
Check the options. The correct option is,
D.
understood it? So
Yes, sir.
this is JMain 2013 question. Any doubt till here?
No, sir. But I have to revise my 11th grade.
What you have to revise?
So 11th grade concepts.
Yeah, that time to time I will dictate the things. Don't worry about that. Sometimes students have in their mind they are weak in mechanics and they are, so they cannot solve. That is not, that will not happen. If there is any concept of class 11 comes anytime, I will try to dictate you, so that will not be any problem. If some integration kind of things time, I will dictate it separately, I will explain it. If mechanics concept comes, I will dictate it separately, so that will not be